this is something you've already got down. 2x minus 3 squared plus 9 equals, what do we want to go with here? We'll go with 107. 07 there. What would you do to solve something like
Subtract
this?
9 from both sides.
Okay, I like it. What does that give you on the right side of the equation? I'm not anti-calculator. You're welcome to.
98.
Yeah, if you need a calculator, you're allowed to use one by all means. Okay, keep going here. What would you do next?
And then I think you distribute, right? The 2 into the x and 2 into -3.
So this square.
Oh, I know wait, no, I don't know.
It's kind of like the last problem here. What did you do to?
You divide.
You divide. The difference here is there's stuff in parentheses. You can't get to it until you undo the square. So you're going to divide both sides by 2. So this is x minus 3 squared equals 49. All right. Now what do you see? What looks familiar to you there, if anything?
Do you take the square root of x minus 3?
You do.
Of the 2. Yeah.
Now tell me what the right side becomes, please.
Let me get calculated. Hold on. 7.
Is that your only answer, or is there another one?
Wait. Is it not 7?
That's like half the answer.
Is it 7 and -7?
Yes. Okay. So really important here. When you take the square root of both sides, it's plus or minus always. You have to like remember that, believe that. Even if you don't know why, you just have to go with it. Unless you want more detail, then of course I can give that to you. So now that's actually 2 equations. It's x minus 3 equals 7, x minus 3 equals -7. Could you solve both of those for us, please?
For the left one, you add 3 to both sides.
Same on the right. You're going to add 3 to both sides for both of them. So just give me the final answers there, please.
Okay. So one would be x equals 10. One would be x equals 4, -4.
Good. Okay, let me give you another one to try here. We'll make it a little bit easier on you. I kind of went a little nuts on that one. 5x squared minus 180 equals 0. Could you solve that for me, please?
Add 180 to both sides.
So this time I want you to work it out as much as you can on your own and just give me the final answer. As much as you can. Yeah.
Should I get paper?
I would recommend that, unless you can do it without it. That's fine with me. But
let me get paper.
Sure.
Mom, I need paper. Go on. Hold up. Paper. Um, 5x. Is it like 6 and -6?
It is very good. All right, so you got that. So there's definitely you definitely got this down. Let me give you kind of one more here to try on your own here before we move on to something else. Basically, I'm just sort of stepping you through the difficulties of these types of problems, and then at some point you've mastered it, which we'll see here on this next one. So go ahead and see if you can work this one out on your own. Any questions on this one?
Wait.
I'm just working out the last one in case you want to look at the notes later on for it.
Would it be -1 and -5?
Okay, so here's how I check. And I'm not saying you're wrong. This is just a way you could use to check. I'm going to put -1 in for X, add 2 to it, and then square it. So -1 plus 2 squared is 1. 1 squared is 1 times 3 is 3. 3 minus 27 is not 0. Now the -5 might be okay. Let's try that here. -5 plus 2 is -3 squared is 9. 3 times 9 is 27. Minus 27 is 0. So this one's good. So let's take a look here because you're really close, right? Like one of them's
Oh,
right.
it's just one, not
Is
-1.
that's right. That's right. Do you see your sign error somewhere there?
Yeah.
Okay. Yeah, it's the math is a detail oriented thing going on here. All right. So let's talk a little bit about quadratic formula. Have you heard of that before?
Yeah, I'm pretty sure.
Okay. And is this maybe something recent or not recent?
Yeah, I think recent.
Okay. So I rely on you to know what's going on in the classroom. Like I'm obviously not there. I have no idea. So let's look at a problem here, something you might already know how to solve, something like this. If I showed you something like this and I didn't put quadratic formula up above there, is there another way to solve this that you might remember from class?
Don't you label like one part of it is A, one part of it is B, one part of it is C?
Yeah, but forget that I put quadratic formula up here.
Um,
You're trying to do it with quadratic formula. Quadratic formula is like a hammer. It works for everything, but you don't always need a hammer. If you're screwing in, light bulb, you don't use a hammer. What any other ways you might think of to solve something like this?
Add 7 to both sides.
Okay, so you're going down the path of completing the square, possibly. How about just plain old factoring?
Yeah.
Okay, so like two numbers that multiply to -7, but then add to -6. Have you heard of that before?
Yeah.
Okay, so here, I'm going to give them to you. -7 and +1, x minus 7, x plus 1, like that. And then we're going to set both of these equal to 0. Tell me if you've seen this before, if this is totally foreign to you.
I think I've seen this before, yeah.
Okay, so it's a little questionable, but to solve these, you add 7 to both sides. So we know that x is 7 and x is -1. Okay. Now we're gonna solve the same problem using quadratic formula, which is what you were telling me. You said, hey Matthew, it's ax squared plus bx plus c. Can you tell me the values of a, b, and c?
Isn't A just, wait, is A just 1?
It is. There's a 1
A
in
is
front of x
1,
squared that's not written.
and then it's -6 and then -7.
Good. Okay. Now let me write down the quadratic formula. This is probably something that you have seen in class. We'll see. B squared minus 4ac all over 2a. I'm not asking you if you've memorized this, but have you seen this before? Does this
Yeah, I
look
know.
like, okay, great. So the main issues with this formula is that there's a lot to do. And there's a lot of places where you can make mistakes. Now, so far, I've actually been hearing a lot of good stuff from you today. I haven't been hearing like, I have no idea. I've never seen that before. I'm not sure. So I'm going to be optimistic here. One thing I'll throw in is that sometimes it's better to write these variables in parentheses, especially when you're substituting numbers. So I'll show you that now. Negative b is -6. It's not that this negative matches that negative up there. It's that it is -6. So I put in parentheses, plus or minus the square root, parentheses, -6 squared minus 4 times 1 times -7, all over 2 times 1. Okay. Strongly recommend that. Do you play any sports by chance?
Lacrosse.
Lacrosse, you're a lacrosse player. So if your coach says, hey, this would be really good for you to do, whatever that is, I don't know anything about lacrosse. It's probably a good idea to listen to him, right? He's the expert. They're trying to look out for your best interest. Same thing here. Like most of the mistakes are made inside the square root here. Okay. So what I want you to do is just look at the part inside the square root. Keep in mind, this is a subtraction symbol. Now, do you multiply or square before you subtract, or when do you do the subtraction, I guess is my question to you.
Wait.
You got a square here, multiplication.
Hey, don't you multiply the 4, the 1, and the -7?
Yes.
First, yeah.
And you square the -6 before you subtract.
Yeah.
Okay, so could you try doing this for me, please?
Yeah.
Now, hang on a second. Before I know I just said to do it. Are you allowed to use a calculator in the classroom?
Yeah.
Now, what kind of calculator are you using?
It's some like school calculator, but it's I think a math calculator.
Okay. All right. Yeah. So go ahead and if you've got one, please use that. If you're going to use your phone, I'd like to give you a different calculator to use because it'll work better, less chance for errors.
All right. I don't have a graphic calculator.
Okay. So here's what I'm going to do. Drop this in the chat here. I'm not sure if you've seen this before.
Oh, Desmos, yeah.
The scientific calculator, the reason I like it is you can actually enter it exactly the way it's written. And what that does is you don't have to think about like, well, how do I enter this in my calculator? You just write it the same way that you've been used to, or you type it in the same way you're used to writing it. So I just opened it up here. I want you to see that if you type exactly the way this is written, you will get the answer. I'd like you to do that if you can for us, please.
All right. -7. 64.
It is 64. Good. Okay. Now that's just one piece of it. Okay. That's just this part up here. So I'm going to just kind of, reset the problem here by grabbing, this awful equation, bring it down here. So here's what you've done. You've told me that the part under the root is 64. -6 becomes 6. 6 plus or minus square root of 64 over 2. Is that okay? What I've done there? Clear?
Yeah.
Can you tell me the square root of 64?
Oh, yeah. Does it? Oh, it does. 8.
It's 8. Now, just like we were doing earlier, there's actually two things here. There's 6 plus 8 divided by 2. And 6 minus 8 divided by 2. And the reason is there's what's called these implied parentheses. They're not written, but they're there. You're supposed to know that they're there. And they tell you to do the numerator first, which means you have two possibilities, 6 plus 8, 6 minus 8, then you divide by 2. Could you calculate those for us, please?
Oh, yeah. Wait. The left one is 7.
Okay.
Wait, what did I just do?
Take your time.
My phone's like being weird. Wait, is it 2? Wait, no. Yeah.
It is not 2.
Oh, wait.
Give it another try.
Wait, what? -1?
Yes.
Okay.
Now those numbers should look familiar to you. Let's go back and look. Remember how we started out by factoring this thing? And we got those two answers. Okay. So the idea with quadratic formula is that it's in some cases looks like a really long, awful, complicated process. And to some degree it is, but it does work. It actually always works. But we want to be careful here because using it all the time could be a real pain. So let's look at another problem here. Let's look at something like this, like x squared plus 5x plus 4 equal to 0 here. Can you tell me the coefficients of A, B, and C, please?
1, 5, 4.
Good. All right, now, rather than writing the whole formula, that part under the square root, that's really where most of the mistakes are made. Could you calculate B squared minus 4AC for us, please?
B, so 5. Oh, 5 to the power of 2 minus 4. And then parentheses 1, 4. 9.
It is 9. Good. All right. So let me write out the entire formula here. Minus B plus or minus the square root B squared minus 4AC all over 2A. Are you typically given an equation sheet or note card or something you can take to class when you have tests?
I have like a foldable here with like, it shows how to like the formulas.
Okay, so something like this would be on there, is what I'm hearing, which is good because
yeah.
okay. Well,
Yeah,
probably
I have
it is. Hopefully there's no gap there. All right, whatever. The point is like I'm trying to find out if you need to memorize this, and it doesn't sound like you need to. So this is minus B plus or minus the square root of 9 all over 2 times 1. Okay. All right, now could you just step me through the problem here? Tell me what to do next. I'll write it down. You tell me what you see.
Take the square root of 9.
Okay, that's
which is
3. Okay, plus or minus over 2. Okay, now what do you see? What's the next thing to do here?
Do you add -5 and 3 and then subtract -5 and 3?
Okay, so maybe break it apart here. Minus 5 plus 3 divided by 2, minus 5 minus 3 divided by 2. Do you want to try that for us, please?
Is it -1
On the left? Okay.
minus 5 minus 3? And then is it -4? Wait, no.
Yes. Yes.
Okay.
I heard a little bit of uncertainty. I mean, there's no way to like know whether they're both negative, one's positive, one's negative. It doesn't work like that. All right. Doing great, actually. Hearing a lot of good stuff. Let me ask you something kind of off to the side here. If I asked you to reduce the square root of 12, would you have any idea how to do that? And it's not a calculator thing. Like if you put this in your calculator, you're going to get a decimal that goes on forever. But there is a way to reduce this.
No, I don't think.
Okay. Related question here is, do you know the smallest prime number?
No.
Okay. Smallest prime number is 2. Sorry?
Isn't it 2?
It's 2. And 2 happens to be the only even prime number. All right, so why is that important? So to reduce this, you first see if 12 is divisible by 2. It is. 2 times 6 gets you back to 12. And then you check 6 to see if it's divisible by 2. And it is. 2 and 3. And what you notice here is all the numbers on what are called the leaves. These are all prime numbers. So 3 is actually your next prime number there. So the idea is 12 is really 2 times 2 times 3. Okay. Still with me on that?
Yeah.
Okay. And we can break this apart as the square root of 4 times 3 because 2 times 2 is 4. And we can further simplify this as the square root of 4 times the square root of 3. There's something that's 4, or the square root of 4 is 2. Okay. So when I said reduce the square root of 12, this is what I was looking for here. Now there's a reason for this, and it's related to the quadratic formula. Let's do one more here before our time is up for today. Let's do the square root of 20. Is 20 divisible by 2?
Yeah, 2 and 10.
2 and 10, and then try it again. Is 10 divisible by 2?
5 and 2.
2 and 5, good. Now, rather than rewriting all this, because this gets really cumbersome to do this, you look for pairs. You say, okay, there's a pair of 2s. Okay, And any pairs can be brought out. So you can bring a 2 out. This 5 doesn't have anything to pair with it. It's left in. So your answer is 2 square root of.
I think I've
5.
done this before,
Based on some of your answers, I think you have. I think you've seen a lot of
but
this.
I think we do like to the 20 and it's like a T-chart. And
Sure.
then we like factor it out.
Yeah, there's a factor ladder approach as well. All right, so let me go ahead and I'm just going to stop the recording here for a moment.